Good morning, guys. This is actually a private video for Sean and Dennis from Battleborn Batteries, but being that probably a lot of other people would be kind of interested in seeing this, I thought I would make it available for the rest of the Kombi crew, and I'm sure Sean and Dennis don't mind us doing that. Now, a while ago, guys, I promised you a bit of an update of how our electrical system was going together. For those of you that don't know, Sean and Dennis from Battleborn Batteries have sponsored our electrical system and provided much of the gear, and they've been doing so for quite a long time as we've been putting it together. And so just now I wanted to give you a quick rundown of like how the electrical system is going in the Kombi, how we put it all together. This is coming ahead of the proper public video explaining our entire electrical system. So if you're interested in this, I'll give you a quick rundown of what we've got, the major components in the system and where it's all sitting and how it's going together. Just to let you know, currently we're in Jersey. This is a month of solid maintenance and last minute checks after we've completed our kind of initial test run with the Kombi, now pretty much finished, 99% finished. We've driven all the way up to Scotland and back down to Jersey on the south coast of England, and everything's going well. And we've just got a month to fix things like this dirty steering box, that's our dirty steering box which was causing us issues. So we'll be fixing things like that, and then we'll be taking off properly on the journey. First leg, Western Australia and down to Morocco. So that's pretty much what's going on right now, but I wanted to show you the electrical systems. Let's have a quick look at that. Okay, so this electrical system that we've been putting together is probably overkill for the majority of camper vans, but we are going to be working off-grid, producing our travel series, and so we need a lot of power so that we can work, and so we've got some pretty significant kit in here. Okay, so first up, this is the star of the show. This is a 100 amp hour lithium ion phosphate battery from Battleborn Batteries. It's basically a direct replacement for, why am I telling you guys this? You make them. But for everyone else, this is basically a drop-in replacement for a standard lead acid battery, but it's about 100 million times approximately better. So we have 4 of these batteries, and although they are small and much lighter than the regular ones, it's still difficult to fit them in this tiny space. Okay, so we have one here. We actually have 2 on this side of the bus to help balance, and 2 on this side of the bus. One of them is here in the living compartment. One of them is under there in the living compartment, and it's a little bit difficult to show you, but it's all snugged down and secured properly and everything is good. So just trust me, there's another one in there. Okay, so we have 2 in the engine compartment too. One on the driver's side, and one over here on the passenger side, and that is our starting battery, which is ratchet strapped next to it, very tight to get those 2 in there. This is where we have the battery temperature sensor on this unit here. Okay, a quick comment on battery location. I know you guys advised me to not put all the batteries in the engine bay, which was the original plan. So on that advice, I have moved 2 of them inside, but because of limited space, I've got 2 of them out in the engine bay still. I know that's not ideal. The great thing about these batteries for everyone else is that they will shut off if they get too hot. So if temperatures rise too much, the batteries won't charge, which is nice. So, and the same with the other. If it's too cold, they will shut off too. So that's good. It means they're safe. I did go for a drive and do some test runs on a hot day here. It's about 85 degrees Fahrenheit. The engine bay got to 115 degrees Fahrenheit, which is well within spec. Obviously it's not ideal to have two of the batteries running at a different temperature to the other two batteries. So that's the situation. Feel free to comment on that if you like. If you'd like to, I'd like to hear what you have to say. The good news about the location in the engine bay is they're directly in the cooling stream of air that comes into the engine, so that there is a positive, or is it negative, vacuum of air being drawn into the engine bay, and it goes directly over the batteries, which is why they run significantly cooler than the actual temperature of the engine and the air intake of the engine, all of which I can monitor from our computer system, which is nice. So that's battery location. Let's have a look at the components that go into the system. Okay, what should we start with? Okay, we've got the Sterling Power 40 amp 12 volt AC charger. So on the outside of the van over here we have a AC plug-in port, basically, to allow us to connect up to whichever AC shore power that we find along the journey. And the great thing about this Sterling Power 40 amp charger is that it will accept any kind of electricity that we come across on the journey, any hertz, any voltage, and it will transform said electricity into the perfect, now programmed custom profile for our Battleborn batteries. It's great. It works incredibly. It charges the batteries in no time at all. So for the most part we're going to be off-grid, but in the situation where we just need to knuckle down and work and it's cloudy or rainy, or we're parked under cover and we can't get our solar to work, we'll be using this so that we can continue to work, and also so we can charge our batteries up if we have depleted them and we've been working in a tunnel or something like that. This for me was necessary for us to be able to kind of use this as our studio HQ when we're parked up outside a hotel or something like that. We can't always guarantee we're going to have perfect solar coverage all day, depending on trees and buildings and things like that. So that's great. The power actually comes in from the mains into this jumper, this AC breaker here, I should say, not jumper. Get to that. That comes in here, and I flick that on. Oh, that's on board. That's AC in. This one that comes into this one, and then it goes off to this, and then that power comes to here. I'll come back to this in a second. The other great thing about this unit is as well as maintaining the batteries, it will allow us to work on grid. So basically it will keep all of our batteries at the optimum charge, and we can use our inverter and everything, and it basically picks up the load that we're putting on it with our computers and things. So it's basically like a really cost-effective way of having an AC hookup without having transformers and everything, and a lot of other kit that we'd have in here. All of the components in this system, bar the inverter, all run on DC, so we don't have an AC hookup for our fridge or anything like that. Everything runs off the Battleborn battery system, and that's much more simple and it's much more cost effective, so we're really happy with that. So for generating power in the vehicle, for generating AC power, even though we are an international vehicle, we are on 110 volts American standard electricity. So we have this Ames Power pure sine power inverter, 1000 watts, which is plenty for what we need to power our two laptops, which is, to be honest with you, mostly what we've got running here. So all of our electricity is provided via that. It goes through another breaker, that is this one here. So basically we can plug in via our standard plug sockets, which we have one down here. This one you'll notice is not a standard plug socket. It's got 2 USBs, and this is an international style plug socket. So whatever types of appliances we might pick up or adapters or anything on the journey, we'll be able to plug in. So that's kind of one of the ways that we're making it future proof or overland proof. Then we have a charging bay up here, so we have AC power also routed behind everything to this unit here, which is also a 4-gang socket, which is international plug sockets as well. So doesn't matter what we plug in, whether it's Leah's Australian MacBook charger or my American computer or the future drones that we'll buy in Morocco or wherever, we'll be able to run AC power on board and work continuously and charge all of our stuff. For the most part, we're trying to keep all of our charging at 12 volts so we don't lose that inefficiency of converting to AC power and then back to DC. So we have got lots of 12 volt systems and lots of 12 volt sockets and USB charge points all around the van in pretty much every single location that we possibly can. Okay, so that lets us charge when we're parked up. This one, also a Sterling Power, is a great bit of kit. This one allows us to charge whilst we're driving. That is a battery to battery charger, DC charger. So it basically takes whatever voltage the standard alternator is putting out and it ramps it up to what our batteries need. It's programmed to charge exactly the right charging profiles for these Battleborn batteries. Okay, so let's just talk about that for a second. Typically speaking, a normal alternator in a vehicle is not designed to put out the charging profile to charge auxiliary batteries. It's designed to maintain a starting battery, and so that's why various devices exist. All of them have their problems, which I'm not going to go into now, but this one is by far the best option that I've ever seen. It's slightly more pricey, I'll give you that, but it provides exactly the right current at all times and boosts up the available voltage. Now, I am having some issues with this, and I believe that the issues may be to the limited power that is putting out from my alternator, so I'm currently troubleshooting that. I've been speaking with Sterling Power, and I've just bought one of the clamps to clamp around the various cables to see exactly what current is flowing through, because we're only getting about like 300 watts, so maybe like 20 odd amps out of our 55 amp alternator, and this thing is rated for 30 amps. That's very conservative. Most people with larger alternators and larger vehicles and more modern vehicles will have a higher output alternator, and so if you were going to get something like this, you'd want to get like the 60 amp version. Oh shit, just spilt water, bear with me. That's quite a lot of water. This is also absolutely necessary if you have a regenerative braking system. Like modern cars have much more efficient systems where they'll basically turn the alternator off when you slow down or stop, and this will ensure that it continues to get the right output from the alternator to charge your batteries. Obviously our Kombi doesn't have that, but it's still a very efficient, a much better way to charge our batteries. Okay, so that's how we basically get power whilst we're driving. How do we get power when we're off grid? We use this. This is a 30 amp MPPT charge controller. Doesn't have any LCD display on there, which at first when I got recommended this one from you guys, I thought, you know, where's the LCD display? But what you knew and what I didn't is, I don't have it with me, is that there is a Bluetooth connector which you guys kindly sent me. It's amazing being able to see all that information, the history of what kind of charge you've got, to know exactly when your batteries have reached float, and then you don't, at that point you can start charging your other devices like your laptops and everything like that. Absolutely phenomenal piece of kit. Brilliant, works really well. We've only been able to test it for the last pretty much month because we've only just got our solar panels. So that and the MPPT controller is much more efficient than any previous one that we've had. So I'm very happy with this piece of kit here. Let me show you the solar panels real quick. Let's get out the bank. Okay, here are the solar panels. So we've got 250 watts on the back and we've got 120 watts on the front, which basically gives us 370 watts. Got them set up on a latch system with the idea that we'll be able to adjust them, make them adjustable in the future. So on that side there's a hinge, so we'll be able to like hinge them up, and I just need to fabricate some props or something to basically make that work so that we can adjust them towards the sun and get the most out of our power. So 370 watts. It's a lot of glass on the roof. It's the absolute max that we could fit on there, and it's slightly too big for the profile of this vehicle, but we need it to be able to work off grid. And with this MPP controller and that amount of solar on the roof, we are finding that we are getting plenty of power to be able to work. It's absolutely phenomenal. I'll come back to the results of this whole system at the end. There's just one more thing that I want to show you. So here is our fuse panels for all of our 12 volt stuff. So basically, you know, things like a fridge, water pump. We might have fridge, water pump, fan, 12 volt sockets, lights, things like that. There's a gas detector if there's any leaking gas. Our water filtration systems, so we can drink out of rivers and stuff like that. So lots of different components, all individually separated for troubleshooting. So the system has been designed really well. Last thing I want to say about this whole setup is we can isolate all of the system here, so that disconnects the batteries from all of the charging devices and all of the load. That's good from a safety point of view. In case you're wondering, that is our ECU for our engine. Okay. Here we've got a DC breaker bank. This is basically so that we can disconnect each of the components in the system. This one stops the inverter from putting out too much power into our system, so that will break here. That's the output. This one allows us to turn off our alternator charging, so if we're troubleshooting something we can isolate it here, or if for some reason it's overloading and taking too much power from the alternator and it's affecting the engine management system, we can temporarily turn that off there. Number 3 allows us to prevent the AC charger from putting in power into the system. Number 4 is a double pole breaker on both the positive and negative coming in from the solar panels. So that will allow us to cut the solar panels off the system. And number 5 stops the solar charge controller from adding power to the battery. So we have it isolated on both sides of the circuit. And number 6 is a spare in case we run into problems on the road. Okay, the last piece of magic of this whole kit is this little block here, which is a shunt. Victron Power shunt, which basically allows us to control via an app. Okay, so via this app we are able to see, first of all, let me show you the BMS. Okay, so this allows us to see every single amp that comes in and out of the system and the state of charge. This whole system has been parked up for at least a week now. It's been turned off, it's still at 100% state of charge. That's quite phenomenal. You can see our deepest ever discharge was 208 amp hours. Let's turn on the solar coming in. We go back to the solar. So I can also see on here how much energy we're getting from our solar panels. So it's very cloudy outside today. As you can maybe see, it's a thin layer of cloud, but it's complete cloud cover. It's fairly bright. We're getting around 200 watts of solar coming in. So it's taking that, because it's MPPT, it can constantly shifts the amount of power that it's got, which adjusts the voltage and amp and puts out a steady amperage for the batteries in the right parameters for the battery. So we're currently 13.6. that will try to make it up to 14.4 to be 100% charged. And you can see here, we can see the history of how much time we spent charging, and that was obviously a day we were working off grid, using a lot of power. So that just gives you a bit of a tease of what we've got to monitor the system. So I'll go into more detail in a future video once we've had time to properly test everything and report back on the results. But so far we've had quite great results working off grid. We've had plenty of power to work off grid for as long as we want to, and for the most part, when we're having a filming day, we rarely get below 90% state of charge, just using the kind of fridge and cooking and living in here and charging our batteries for filmmaking and charging the drone and things like that. We rarely go below 90%. I can't tell you what it is when we're working off grid on the computers. We'll be using a lot more power like that, but I'm very interested to take this system out for a proper test run over the next few months through Europe and Morocco and everything like that. And also looking forward to making the proper video that explains all of this stuff, and involving the interview we did with Dennis in Vegas when we picked up the batteries and everything, and talking about lithium and all of that stuff. So looking forward to putting that video together. That, I think, is about 3 videos out on our schedule now, so it's very nice to be able to see that that one is coming. It's been a long way out whilst we build the rest of Boomerang and the whole studio and everything. That's taken way longer than we expected, so thank you for your patience. Guys, if anyone's still watching this technical video, thank you for sticking through, and Sean and Dennis, thank you so much for making all of this possible. Seriously, we are absolutely blown away with how good this stuff is, and having your support and mostly your patience as well whilst we did all of this. Like, you've been absolutely awesome, and we're very much looking forward to telling the world about this system, because we know a lot of people will want to see it, and hopefully it, you know, sends a few more eyeballs your way on your gear, because you deserve it. We shopped hard to find the best stuff, we found you guys, and we're very, very lucky that we did, and we're very proud to be able to talk about this stuff. So thank you for your support. I will catch you soon. Bye bye.